Hi, I'm Selva Prabhakaran. In this one, let's understand what is the law of large numbers. Basically, this is what the law says. As you increase the number of trials, the results will approach the true value if such a true value exists. This is what it says. Let's understand this with an example so that it is very clear. Usually when explaining this, we will take a very simple example, the coin toss. The reason I will tell you, usually if you toss a coin, it will come as either heads or tails. You can also take a practical example such as finding the effectiveness of a drug, right? If you are giving a drug to a patient, it might cure the patient or not cure the patient. This is also one of the examples you could take, but the problem is, in this kind of an example, we don't know the true probability of the effectiveness of the drug. But according to the law of large numbers, there exists a true probability. Now, if you are going to make this assumption to this kind of an example where there is the effectiveness of the actual effectiveness of the drug is known, then you can apply the same ideas. Let's work with the coin toss example. Alright, so you are tossing the coin 10 times. One single coin, you are tossing it 10 times. Out of those 10 times, 4 times you are getting heads and 6 times you are getting tails. You could also get 5 heads and 5 tails also. But practically that it will not happen most cases. Sometimes you will get 3 heads and 7 tails also. For this example, to be little bit more closer to reality, we are assuming that there are 4 heads and 6 tails. So in this case, the probability of getting a heads is going to be 4 by 10, which is 0.4. Similarly, say you are doing the same experiment 50 times. Now out of 50, you might expect something similar to this situation. We are putting 26 heads and 24 tails. Likewise, 100 times you do it, we get 51 times heads, 49 times tails. 1000 times, 498 heads, 502 tails. Say this is typically how you would expect the results of a coin toss. It might vary a little bit, but typically this is a fair example. Now let's try to compute the probabilities also along with these numbers. For the first case, we know the probability is 0.4. Now for the second case, we have 26 heads out of 50 tosses. So that would be 0.52. Likewise, for the third case, we have 51 heads for a total of 100 tosses. So this probability is even more closer to the actual of 0.5. Likewise, if you keep increasing the numbers, the probability of heads is tending towards the actual probability. And that's what the whole law itself is all about. As you increase the number of trials, the observed probability approaches the truth, which in this case is 0.5. So the coin toss example is a binary case where your result can either be heads or tails. Let's look at another case where you are measuring the duration of sleep. Alright, you want to measure the average duration of sleep from a given population. Say you take 5 members or 5 trials and measure the average of the duration of sleep amongst these 5 members randomly chosen. You get an average to be 7 hours 10 minutes. When you do it for 100 people, this changes. When you get it for 500 people, this moves even more closer to reality. So now, amongst these 3 different experiments that we have tried out, which one would you pick to be the actual average duration of sleep? We would pick this particular observation because we have more trials done in this particular experiment. So that's the whole idea. Let's now test your understanding of the law of large numbers. So this is the problem statement. Pause the video, have a read through of the entire problem statement in silence. This might be a little bit tricky, so pay attention and try it out. Let's discuss the answers in the next video.